everyone. In this lesson, we'll be looking at transformations of functions. If you're in Ms. Drake's class, we are on lesson number 90. So first we're going to look at a parent function, which is the simplest function in the family of functions. So this is the parent function for an absolute value graph. The equation is y equals, or f of x equals, the absolute value of x. So we'll be comparing all of our functions today to this original parent function, and the vertex is at 0, 0. So we'll be doing transformations, which are either moves or resizes of this function in relation to the original one. So the first example says if g of x equals f of x plus 2, write a function for g of x. So underneath this function, I'm going to write g of x equals, and now wherever you see f of x, you're going to write the original parent function that they give you. So in this case, absolute value of x. I'm going to write the absolute value of x, and then I'm just going to write plus 2 at the end. So that's my new function. Once I have my new function written, I can go to the y equals on my calculator and type that function in. So math over to num, and then 1 for absolute value, ABS. So you type your x on the inside of the lines and then arrow over to write plus 2 on the outside. Okay. We'll go to our table, so second table, and we are looking for our vertex. If you look at the y values, you're looking for the point that doesn't have a matching point. So here we have 2, because the 3's surrounding it match, the 4's surrounding it match, and the 5's surrounding it match. So that point 0, 2 is my vertex, and then I want 2 points on either side. So let me start here at negative 2, 4, negative 1, 3, 0, 2, 1, 3, and 2, 4. You can always plot more, but we do want a minimum of 5 points. So we'll do negative 2, 4's here, negative 1, 3, 0, 2, 1, 3, and 2, 4. Use a ruler or a straight edge of some sort to connect your points. It should make this V shape just like the original one. And because we have two graphs on the same grid, make sure you label it with the equation. So over here I'll write g of x equals the absolute value of x plus 2. Okay. And then it's asking, how is g of x compared to f of x? So how did we take f of x and move it to create g of x? Well, if you look at the vertex, and really every point on the original versus the new function, every point has moved up 2 units. So we say it moved up 2 units. So as a general rule, we call it the transformation rule. If you take a function, f of x, and add a number to it, it's just going to move or shift that function up that many units. So it moves, I'm going to write, this is a number sign, not a hashtag, so it moves that many units up. Okay. Similarly, if we subtract a number from the function will move down. So that's going to be your example on the next page. So pause the video, try the example on the next page, and then come back to check your work. Okay, so example number 2 gave us g of x equals f of x minus 4. So when I rewrote my function, I have the absolute value of x minus 4. And when I put it into my calculator, here's the points I copied, and you have your absolute value graph, and it looks like the entire thing moved down 4 units. So that's what I wrote here, moved down 4 units. Okay, let's take a look at example number 3. So this one says g of x equals f of x plus 5. So we're still adding or subtracting, but this time the plus 5 is inside the parentheses instead of on the outside like it was up here. So when I write my new function, g of x equals, remember the parent function was f of x equals the absolute value of x. So when I rewrite my parent function, I'm going to replace x with whatever inside the parentheses, which is x plus 5. So when I write my function, the plus 5 goes inside the absolute value lines instead of on the outside. Okay, so go ahead and put that into your y equals. So math over to num, absolute value, and I have x plus 5. Let's make sure to delete that. Okay, go to your table, and remember you want your vertex and then 2 points on either side. So let's see. Oh, here's my vertex at negative 5, 0 because the 1's match, the 2's match, and the 3's match. So I will do this point, the vertex, and then 2 points above and 2 points below. So negative 7, 2, negative 6, 1, negative 5, 0, negative 4, 1, negative 3, 2. And again, you can plot more if you want, but that's all I'm going to do for now. So I have negative 7, 2, negative 6, 1, negative 5, 0, negative 4, 1, and negative 3, 2. Okay, connect your points. Make sure you label with your new function g of x equals the absolute value of x plus 5. And then how has the graph of g of x changed compared to the graph of f of x? Well, it still moved, but how many units did it move and in what direction? It moved left how many units? 1, 2, 3, 4, 5. Okay. So if I add or subtract inside the parentheses or inside the absolute value lines, I'm going to be moving left or right. So it looks like if I add, I'll move left, which means if I subtract, I should be moving right. So here is the rule. F of x plus a number moves that many units left. All right, let's take a look at example 4. G of x equals negative f of x. So in this case, I'm not adding or subtracting anything. I'm just putting a negative sign in front of whatever the original function was. The original function was the absolute value of x, so I'm just going to put a negative sign in front of that. Okay, so go ahead and put that into your y equals. Num, absolute value. Oh, you know what, I forgot my negative sign. Negative, math, num, absolute value, x. All right, let's go to our table and look for that vertex. Oh, here it is. All right, my negative 1's repeat, my negative 2's repeat, my negative 3's repeat. So this point here is the one in the middle. So I have 0, 0. I'll do 2 points above and 2 points below. So negative 2, negative 2, negative 1, 0, 0, 1, negative 1, and 2, negative 2. Connect your points. And make sure you label the new function. Okay, so how did the graph change this time when I put a negative sign in front? You can say it flipped, or you can call it a reflection. Okay, we took the absolute value graph, or whatever your original function is, and it was reflected over the x-axis. So the negative of f of x is a reflection. All right, let's turn the page. And we have one more example. Okay, so this time the new function is going to be g of x equals 2 times f of x. So that means you're going to put a 2 in front of whatever the original function is. What was our original function again? The absolute value of x. So when I rewrite my new function, it's going to be 2 in front of the absolute value of x. Okay, go to your graphing calculator again. Put that new function in, 2, absolute value x. Go to your table and find your vertex. Let's see. Here it is at 0, because the 2's repeat, the 4's repeat, the 6's repeat. So my vertex is at 0, 0. And I want 2 points above and 2 points below. So negative 2, 4, negative 1, 2, 0, 0, 1, 2, and 2, 4. Okay, let's plot our points. Negative 2, 4, negative 1, 2, 0, 0, 1, 2, and 2, 4. Connect your points. I lost my ruler, so I'm going to just freehand it. And make sure you label your new function. G of x equals 2 times the absolute value of x. All right. Now, how did the graph change compared to the original? Okay. So it looks like the two lines got closer together. So we use the word, it became more narrow. Or if you want to compare the slope of the lines, you can say that the slope increased. Okay. Another word you may see to describe it is a vertical stretch. So just 3 different ways to describe what happened. Usually the more narrow, the absolute value graph closed up is the most common. All right, so you guys try example 5 and the other example, and you can check the instruction section to check your work, try the homework questions, and let us know if you have any questions. Have a great day.